Hello, Precalculus students. In the previous two videos, we covered questions 1 through 20 on Rutgers Department Precalculus Final Review. This will likely be the final video covering questions 22 to questions 30. So, it says, from 1990 to 2000, the student tuition at the university grew from 12,000 to 18,000. Use an exponential growth model to determine the R, the annual rate of interest for the population, as a decimal accurate to 3 places. So let's think this through. At 1990, there was $12,000. And then, in 2000, it was $18,000. So, then there was 1991, 92, 93, 94, 95, 96, 97, 98, 99, 2000. So, you would multiply by your annual rate once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. So even though 10 years passed, you are multiplying by your common rate 9 times because you did not multiply by your common ratio to get 12,000, the first term. So we could say 12,000 times r to the 9th power, because it's r times r times r times r, 9 times, equals 18,000. Divide your 12,000, because you want to isolate the base. And we have r to the 9th equals 18 over 12. Now the opposite of the 9th power is the 9th root. This is a calculator active question, so we're going to do the 9th root of 18 over 12. If your calculator does not have the x root, which even the scientific calculators have that, so you should, you could just say to the 1 over 9th power, because that's what a 9th root is. So your root equals 1.046081919. It says to be decimal accurate to 3 places. So r is approximately 1.046. Another way that you could have done this, you could have used your geometric sequence formula, because the geometric sequence follows the path of an exponential. Your first term was 12,000. Your rate we didn't know in the beginning. It took 10 years to pass, so 10 minus 1. Notice we get the 9 that we would have gotten here. And it's supposed to equal 18,000. Isn't this exactly the same work that we would have done here? Only the origins, rather than having to draw out this whole demonstration there, you could have just used this formula. So it's up to you what method you feel the most comfortable with, logically figuring it out or using the geometric sequence formula. So that is how you find your common ratio. Okay, so that's part A of this question. Now for part B of this question. Assuming the same growth rate, use R found in part A above. Find in what year to the nearest year the tuition of Rutgers will reach 30,000. So you could use the formula a sub n equals a sub 1 times r to the n minus 1. A sub n is going to be 30,000 because that's going to be the amount accumulated. The initial amount was 12,000 times the common ratio we said is about 1.046 to the n minus 1. You would divide by 12,000 and you'd get 1.046 to the n minus 1 equals 30 over 12. So now, to solve for an exponent, you're going to use logs. Log base, argument. Remember, the argument's always on the other side of the equal sign. Equals exponent. The last step will be to solve for n by adding 1. Don't forget the plus 1. A lot of students will do the log and then forget the operations on the exponent. So we'll put this in our calculator. Just a reminder, if your calculator does not have log base, you can do log of your argument over log of your base. So I get n equals 21.37407,516. So it wouldn't take just 21 years. It would take 22 years for Rutgers to reach a tuition of $30,000. So when did this start? 1990. So we're asking for the year. 1990 plus 22 equals 2012. All right. So now, for question 23, it says, carbon dating is commonly used to determine how old an object is by measuring the amount of carbon-14 that is left in an object as the object decays over the years. This decay process proceeds exponentially with a half-life of approximately 5,800 years. How old to the nearest year would carbon dating say a piece of bone is when the amount of C14 has decayed from its original amount of 100 grams to a final amount of 22 grams? So, this is when we use our exponential decay formula. A equals P times 1 minus R to the T. So, it said that the initial amount was 100 grams. The rate that it's decaying by is a half, so 1 minus a half is just a half. And then to the T. So following this formula, this is what we would get, right? But imagine I plugged in 1 year. What's going to happen is it would be 1/2 to the 1, which is a half. We're saying the 100 halves after 1 year? No. The question's asking us to make it halve every 5,800 years. So we're actually going to have to offset the exponent. So what could I do to T where I plug in a value and at 5,800 years it will equal 1 because we want it to equal 1 so that it halves after that amount of time. Well, if you plug in 5,800 and you divide it by 5,800, that would give you 1. You plug in another 5,800, divide that by 5,800, you get 2. So every 5,800 years, it's going to halve. We just offset the equation. So don't trust this formula if we're talking about time other than years. You could use the general format of it, but you might have to offset it. So now it says, how old is it when it reaches 22 grams? 22 grams is an amount, not time, right? And we're solving for the time. So we're going to have to use logs. The first step is to isolate the base. And we're going to have log base 1/2 of 22 over 100 equals the exponent T over 5,800. Now, on both sides, to solve for T, we would multiply by 5,800. Cancels out. And we can solve this. So in my calculator, I'm typing 5,800 times math log base of 1/2 of 22 divided by 100. The answer you get is T is approximately 12,669.66251. It says to round to the nearest year, so approximately 12,670 years old that bone is. Okay. Okay. Question 24. Air temperature, capital T, varies in a periodic manner, with highs during the day and lows during the night. Assume that the weather pattern is the same for 1 week, and suppose that capital T in degrees Fahrenheit at a particular time of day is given by the function T of T. Where T, lowercase t, is in time in hours, with T equals 0 is at midnight. Answer all answers exactly. So, the first thing I recommend, let's put it in this form. Remember, and they're using sine, so I will show it to you as sine. Y equals A times sine of B times X minus C plus D. A is your amplitude. C is your phase shift. D is your midline. And B, it's not anything directly, but it gives you your period. Your period is 2 pi over that B. So now, if I want it in this form, I'm going to have to factor out the B. So I'm going to have to factor out that pi over 12. So I'll show this factored out. T of T equals 13 times sine of pi over 12 times T. And now I have to divide this, negative 2 pi over 3, by the pi over 12. Because that's what factoring is. You're dividing it out and showing the equivalent product. So that's negative 2 pi over 3 times 12 over pi. Pi cancels out. 12 over 3 is 4. 4 times negative 2 is negative 8. Alright, plus 62. Okay. So, we factored it out. That was just my rough work. Now it's asking, what is the high temperature during the day? So, sine and cosine are sinusoidal functions. That means that they oscillate between the same values over and over and over, right? So, we have our midline, which is the line that splits our sine function down the middle. And we have our amplitude, which is the height that it is going above the midline or the vertical distance from the midline to its lows, the minimum. So T of T is your temperature. So we are talking about our maximum. Your maximum is going to be your midline plus your amplitude. So your midline we said was 62. Your amplitude was 13. 62 plus 13 is 75. So it'll be 75 degrees at the maximums. So now we want to find the minimums. The minimum value is going to be your midline minus your amplitude. So 62 was our midline. Subtract the 13 from the 62. And you would get 49 degrees. So the lowest temperature of the entire day is 49 degrees. Okay? So that's how you find your maximums, your minimums, your midline is in the equation, amplitude in the equation. For C, it says find the temperature at 12 p.m. So the first thing I'm thinking is, what is my time in terms of? Well, it says 0 is midnight. Midnight's 12 a.m. We want to find 12 p.m. So it takes 12 hours to get from 12 a.m. to 12 p.m. Yes. So that means your T is going to be 12. That doesn't necessarily mean these numbers are going to match. We'll see that with 6. So I'm going to plug in 12. T of 12 equals 13 sine of pi over 12. I'm plugging into the original. So I'll erase everything on the original so that you can see it. So pi over 12 times 12 minus 2 pi over 3 plus 62. 12s cancel out. Pi is the same as saying 3 pi over 3. 3 pi over 3 minus 2 pi over 3 is pi over 3. Okay? So now sine of pi over 3. Let's think about that. On the unit circle, it's pi over 6, pi over 4, pi over 3. And remember, 3, 2, 1, 1, 2, 3. All of them are over 2. And they all have a square root on them. So, sine of pi over 3, because sine's the y value, is the square root of 3 over 2. So your answer would be 13 radical 3 over 2 plus 62. It's asking for your answers exactly, so I would just leave it like that. Okay? Alright. So now we're going to do something very similar, but for 6 p.m. So 6 p.m. is 6 hours after 12 p.m. So 12 plus 6 equals 18. So t equals 18 for 6 p.m. So now we're going to have to plug in 18. And again, I'm plugging into the original formula. Pi over 12 times 18 minus 2 pi over 3 plus 62. So 18 over 12 is 3 over 2, so 3 pi over 2 minus 2 pi over 3 plus 62. There's sine 13. So in order to be able to combine fractions, you need a common denominator. So least common multiple between 2 and 3 is 6. I'll multiply by 3 over 3, 2 over 2. That's going to be 9 pi minus 4 pi, which is 5 pi over 6. So 5 pi over 6. So we're going to take sine of 5 pi over 6 plus 62. So this is how I would recommend doing this. I would figure out where 5 pi over 6 is. You could convert to radians if you'd like, or just take it 1 pi over 6 out of time. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So this reference angle will be the same as this angle right here. Pi over 6. Now, we have to remember all students take calculus. So for sine, which we have here, it's going to be positive just as it is in quadrant 1. So that means that it's going to be the exact same value as sine of pi over 6. Sine of pi over 6 is 1/2, right? 3, 2, 1, 1. So 1/2, it stays positive because it's quadrant 2 and we're talking about sine, plus 62. That would be 13 over 2 plus 62. Since this is a numeric value, I mean the other one was numeric as well, but it had an irrational number. Since this is easily added, we could just do it. 13 divided by 2 is 6.5. 6.5 plus 62 is 68.5 degrees. Okay. So that's how you do A through D. We'll also do E. I'm just going to erase all this. Okay. So now for our period. your period is going to be 2 pi over b. And remember, when we divided out the b, it was still pi over 12. So period equals 2 pi over b. We have 2 pi over 12. That's 2 pi times 12 over pi, because keep change flip. Pi's cancel out. 2 times 12 equals 24. Time is in hours. 24 hours. Which makes sense because days are the cycle here. Your temperature is going highs and lows throughout the day. It takes 24 hours to repeat the cycle. All right. Question 25. We have, so if I had y equals a times b to the x, in this case, this would be your y-intercept. This would be your base or your common ratio. Penelope, you gotta come down. Sorry, that's my dog. Base or common ratio. That's the rate that it's going up by. That's for a basic exponential, right? If I said y equals a times b to the x plus c, now it's being shifted. Let's say c is positive, up c. If it was negative, down c. So your y-intercept would change. Your y-intercept would then be a plus c, right? And we know with exponentials, the c is your horizontal asymptote. So that's just a quick refresher on exponentials. So let's see where this is approaching. It looks like this is approaching half that distance. Would have been nice if they drew the asymptote, but they didn't. So the asymptote is at y equals negative 5. So your b is negative 5. So now, for a, you could actually just plug in a point if you want. You can't really plug in 0, because anything to the 0th power is 1. And then that would cancel out, and you would find what your y is at x equals 0, which is your y-intercept. But you could plug in a different point. So let's plug in 5 for y, because it's xy, right? 5 for y, a to the second minus 5. So I'm going to add 5 to both sides. 10 equals a squared. Take the square root of both sides. We'll say a equals the square root of 10. Y equals the square root of 10 to the x plus b. In order to be an exponential, the base has to be positive. Because if you think about it, then if I had an odd let's say it was negative. If I had an odd exponent, then it would be negative. If I had a positive exponent, it would be positive, and it would just be alternating. It wouldn't look like an exponential. So your base has to be greater than 0. Okay? So this is your a, this is your, well, I didn't write the b. The b is negative 5. Silly mistake there. Okay? So this is your b. All right? 26. A ramp is 7, oh, and this is calculator active. A ramp is 17 feet in length, rises to a platform that is 4 feet above the ground. Find the angle, theta, that the ramp makes with the ground. Give your answer to 2 decimal places. So we have our opposite over our adjacent, that is in SOHCAHTOA, that is tangent. So tangent theta equals opposite 4 over adjacent 17. if we wanted to find the angle, we use our inverse trig function to find the angle. So you would, because it's inverse, you're going to switch x and y, your input and output. So the inverse of tangent of 4/17 equals theta. You might also write arctangent. They mean the same thing. So I'm going to put this into my calculator. Typically when we talk about angles, especially if we're talking about a real world situation, we talk about it in terms of degrees. So I'm going to switch over to degree mode. So I'm going to do second tangent of 4/17, and I end up getting theta equals 13.24051992. 2 decimal places, 13.24 degrees. Okay. Find the length of a 25-degree arc with radius 12 inches, accurate to 2 decimal places. So we know the formula for arc length is S equals R times the theta. Theta has to be in radians. So our radius is 12 inches. Now you have 25 degrees. To convert from degrees to radians, you multiply by pi over 180. Remember the trick, right? Usually radians have pi in it, so you have to have pi in the numerator. But if you wanted to convert from radians to degrees, you want to get rid of the pi because degrees don't have pi in it, usually. So you could divide by the pi. So 25 over 180 is 5/36. So it's 5 pi over 36 simplified. So I'm going to do 12 times 5 pi over 36, which is just 5 pi over 3. It wants it to the nearest 2 decimal places. So let's put this in our calculator. 5 times pi divided by 3. S is approximately 5.235, so 224. Okay. And this is inches. Okay. Question 28. 2 trains, train A and train B, leave a train station at 10 a.m., traveling along straight tracks. One train is 80, and so let's say we have these trains. You have train A and train B. Train A, it says respectively, so it's traveling 90 at 80 miles per hour. Train B is traveling 90 miles per hour. They're both on straight tracks. Let's read this. If the angle between their directions of travel is 118 degrees to the nearest mile, how far are the trains from each other? So let's think about this. The trains are both moving on straight tracks. We want to know how far they are, so we want to find x. Okay. The angle that they are from each other is 118 degrees. The angle between their directions. Okay. So the wording of the question is a little confusing because you might make the assumption that straight tracks are parallel. It doesn't say that, so we can't make the assumption. So let me reconstruct this drawing. All right. So this train, let's say, is going on a straight track this way. This train is going on a straight track this way. So let's say we make a triangle like this. This is how far the trains from each other at 11:30. So if this is going 80 miles per hour and this is going 90 miles per hour, they're both going to be different distances. 80 miles per hour after an hour and a half, because from 10 to 11:30 is an hour and a half, would be 80 plus 40. 80 plus 40 is 120. So this is going to be 120 miles. This is going to be 90 plus 45. So that would be 135 miles. And then it says the angles between their directions are 118 degrees. So it's not necessarily a right triangle, right? We want to find this distance at 11:30, where they're going to be, right? So there's two things you could use. You can use your law of sines to find the angles, and then after finding another angle, you'd be able to find the distance. Or you could actually use your law of cosines right away. I'll show both ways. So the straightforward method would be law of cosines, but I'm not quite sure if you learned that, because I know the last thing we went over was law of sines. Law of cosines is let's say c squared equals a squared plus b squared minus 2ab cosine c. That's your law of cosines. So let's say that this is c. Alright? Because that's the angle we're given. Then this would be c. And then we could say that this is a, this is b. So then this is a, this is b. And then you can just plug in. So we're solving for x. So x squared equals a is 135 squared plus b is 120 squared minus 2 times your a again. A is 135. Makes it very easy when you label them. Your b is 120 times cosine of the angle in between, so 118 degrees. And this is a calculator active question, so we could put this in our calculators. 135, let's see, 135 squared plus 120 squared minus 2 times 135 times 120 times cosine of 118. Let me just make sure I'm in degree mode because this is degrees. Yep, I'm in degree mode. So I end up getting 47,000 and whatever. I'm going to take the square root of that. Take the square root. And we just solved that x equals 218.7141482. So that means that how far are the trains from each other? Does it say like nearest mile? So about 219 miles, right? That's law of cosines. Okay? So that's what we got using law of cosines. Again, like I said, I'm not quite sure if you learned law of cosines or if your teacher's planning to teach you law of cosines. So let's try law of sines, because I know you learned that. It's really just about finding the right information, right? So, law of sines is sine A over A equals sine B over B. Oh, no, you can't use law of sines, because you would have 118 over x, and then 120, you don't have a b connected to it for a, and 135, you don't have it. Okay, so yeah, you have to use law of cosine. So let's say your teacher didn't teach it to you. I'm assuming it won't go on your final, but the department final, let's say the teacher uses the department final, they might expect you to know it. So that is what you'd have to use here. Okay. All right. Given t equals 4, complete the following. Use t equals 4. Sketch on the unit circle the approximate location. It's a calculator active question, so t equals 4, I'm assuming is in radians. So radians, again. Radians typically have pi in them, right? This one doesn't. But this is how I remember it. They typically have pi in it, so to convert to degrees, you would divide out the pi. So pi is in the denominator. So I'm going to do 4 times 180 over pi. And you get 229.1831181 degrees. So that's going to be in between 180 degrees and 270 degrees. So that will be over here. So that's your terminal ray that I just drew. Sketch on the unit circle the approximate location of... Okay, that's right here. The initial ray would be right here, right? So then your rotational diagram, because it's positive, would be going counterclockwise. All right. That's your answer to A. For B, it says find the reference number for T. Okay. So they gave it to you in radians, so you might as well do it in radians, right? So that's going to be 180 is the same as saying pi, right? So that's going to be 4 minus pi. 4 minus pi. Okay. That's approximately 0.8584. So that would go up to 0.86 if we're doing 2 decimals. So your answer is 0.86. What is the terminal point determined by T? Okay. So you have the angle. You have what the reference angle is. Terminal point. So T equals 4. The reference angle is about 0.86, or 4 minus pi. Oh, it's on a unit circle. Okay. So, in my calculator, because calculator active, we know that this is cosine, and this is sine. And I'll use t since they're using t. So, cosine of cosine of 4 minus pi. Let's make sure I'm in radian mode. Maybe cosine of sine of, let's see. What is the terminal point determined by t? I wonder why it's giving me this. Oh, because I'm in degree mode. Cosine of 4 minus pi. There we go. Huh. So it's t equals 4. So I'm going to do cosine of 4 negative 0.6536436.209, approximately negative 0.65. Sine of 4 is negative 0.7568024953, approximately negative 0.76. It's negative negative because it's in quadrant 3. So it's about negative 0.65, negative 0.76. All right, so that is 29. Not terrible. Just make sure you don't make the mistake I was making with degree and radians. If it's in radians, then put it in. Make sure you're in radian mode. It's worth it to check each question. The top of a volcano is viewed from a safe distance of 20,000 meters, level to the base. Okay, so it's viewed from here, level to the base. The angle of inclination is found to be 22 degrees. If the angle of the incline from the base of the volcano to the summit is found to be 42 degrees to the nearest foot, how high is the volcano? So, let's see what we have. We can do if you're going to do law of sines, you're going to have to use some geometry. Me personally, I probably would do a systems. Maybe I'll show both methods. Yeah. I could show both methods if you'd like. But I know you were learned law of sines, so I'll do law of sines. So this is a 180 degree angle. I don't typically think to do geometry first. So I'm going to do 180 minus 42. So that's 138 degrees If I want to find this angle, I can, right? 180, because all the angles of a triangle add up to 180. It's 20. So this is 20 degrees here. All right. So now we could actually find by law of sines, we can find this length here. Sine of A over A equals sine of B over B equals sine of C over C. So let's use what we have. We have sine of 20, and this is in degrees, so we're going to have to be in degrees. Degree mode. Sine of 20 over 20,000 equals sine of 138 over x. So then that means we could cross multiply this times this times this, which would lead to 20,000 times sine of 138 degrees over sine of 20 equals x. All right. Let me just make sure I'm in degree mode now. 20,000 times sine of 138 divided by sine of 20. You get x equals 39,128.14022. Okay. So now I have that. I could get this length here. Oh, this is a right triangle. We could actually find this angle too. So that's a right triangle. 22 degrees, so 180 minus 22 plus 90 equals 180 minus 22 plus 90 equals 68 degrees. And then in order to get this, do we need that? We could just use the big triangle probably. Yeah, we could use the big triangle. So let's use the big triangle. This big right triangle here. You have 68 degrees. We said this whole thing is. So then we have 22 over x. So sine of 22 over x. Right? Sine of 22 over x equals sine of 90 over that number that we just found. 39,128.14022. Alright, so cross multiply, divide by sine of 90, you would get x equals sine of 22 times that big number, 39,128.14022 times sine of 22 divided by sine of 90. So I'm going to take that big number, multiply by sine of 20, 2, sine of 22, divide that by sine of 90, and I end up getting my height. My height is 14,657.65 931. So it says to how high is it to the nearest foot? The height is approximately 14,658 meters. Okay. That's how you would do that using law of sines. I know it's a little complicated. Personally, I probably would think of it as a system. Yeah, I'll show you that as a system. I have some time in the video, I think. I think there's only one more question. So, I have these two right triangles, right? I have this one, and I have this one, right? All with this angle. So then, we want to find the height, so I could call it h maybe for height. Don't confuse that with hypotenuse, because I'm going to be saying hypotenuse in a moment. Height. And then we have our adjacent side. We actually don't have the adjacent, but let's see what we could do. So we have tangent of 22 equals your opposite over, because if you think about it, we have part of your adjacents, right? So we'll say this is adjacent 1. We'll say that this is adjacent 2. Okay? So we have our height over adjacent 1. So that's like saying adjacent 1 times equals tangent equals h over tangent of 22. Alright? Degrees. We could do the same thing for this one. Tangent of 42 degrees equals height over adjacent 2. I want to make this adjacent 1. We'll make this smaller one adjacent 2. Over adjacent 2. So then we have adjacent 2 equals h, because it's the same height, over tangent of 42. So now, if we're trying to find, well, if we have this piece of information, we know that adjacent 1 minus adjacent 2 equals 20,000 meters, right? That's what we got here. So then we have, let's do it. Let's subtract those. H over tangent of 22 minus h over tangent of 42 equals 20,000. So if we were to solve this, let's say we wanted to get rid of all of our denominators, we could multiply by all our denominators on both sides. Tangent of 22, tangent of 42, just makes it easier. Whatever you do to one side of an equation, you do to the other. So tangent 22 would cancel out there. So we would have h times tangent of 42 minus here tangent of 42 would cancel out. So h tangent of 22 equals 20,000 times tangent 22, tangent 42. We could factor out the h if we want. So we would have h of tangent 42 minus tangent of 22 equals 20,000 times tangent of 22 times tangent of 42. And then just divide that on both sides. And that's it. This is personally how I would do it. But your teacher might want to see law of sine since she taught it. All right. So let's put this in our calculator just to verify. So h equals 20,000 times tangent of 42, tangent of 22, tangent of 42, tangent of 22, tangent of 42. Divide that by, in parentheses, let's make sure this is in parentheses, tangent of 42 minus tangent of 22. And I end up getting 14,658 like we did before. So height equals 14,658. So you notice we get the same exact answer, right? Okay. So that was question 30. Lastly, we have question 31. A pilot in an airplane is flying at, so let's draw a little airplane. Maybe I don't know what an airplane looks like. Flying at 25,000 feet. Sees two towns directly ahead of her in a straight line. The angles of depression are to the towns are 25 degrees and 50 degrees. Okay. So that means here and here, let's say these are the two towns. Maybe I also don't know what a town looks like. So, this will be the larger angle, 50 degrees. And this will be the smaller angle. 25 degrees. So, we want to know, to the nearest foot, how far apart these towns are. Okay. Yeah, wrong spot. Sorry. This is supposed to be 25 degrees. This is supposed to be 50 degrees. Okay. So we have 25 degrees and we have 50 degrees. There we go. That makes sense. All the heights are 25,000, right? Yeah. So that's how you draw your angle of depression. This is going to be your 90-degree angle. So you have your angle. So 25 degrees, 50 degrees. Okay. So then we have our opposite side, and we're going to want to find the adjacent sides, right? So opposite over adjacent tangents, right? So we have tangent of 25, because we're going to do the bigger triangle first. Tangent of 25 equals opposite 25,000 over adjacent. So our adjacent in this case is going to be this big long side. And then we're going to find the smaller one. Tangent of 50 equals 25,000 over x okay. So then I could say x1 and x2 if you want. So this will be your x1, this will be your x2. So then I have x1 equals 25,000 over tangent of 25. x2 equals 25,000 over tangent of 50. And we're going to subtract those. So 25,000 over tangent of 25 minus, let me do it separately so I could copy and paste. 25,000 over tangent of 50. I'm going to subtract those two values. And I end up getting approximately 32,635 feet. So x1 minus x2 equals 25,000 over tangent of 25 minus 25,000 of tangent of 50, which equals approximately 32,635.18223. It says to the nearest foot, so that is approximately 32,635 feet. 32,635 feet, and that's your answer. That's how far this is. Okay. All right, so hopefully this helped. Have a great day, everyone.